So yeah, we were talking about this idea of function notation yesterday, guys, and we said, hey, anytime you have the f of x like this right here, what do you have to change it to?
Y.
So we're calling this, how would you rewrite this?
Y.
Y equals 3 over 2x negative minus 1.
Okay, so we've taken function notation, put it into function form, furthermore, slope-intercept form, right? So we've done this. Graphically, what would this look like, or how would I start?
Y, put -1 on the y.
Negative 1 here. Good.
And then up 3 over 2.
And then from there, your rise and run is 3 over 2. So rise 1, 2, 3, and run 2. Boom. And those 2 points determine that function right there. Okay.
Hey Parsons, she said okay.
Funny. She knows what I'm talking about. She knows I always win. All right, so and that's what you get right there. So you guys feeling pretty good about this? All right. So yesterday we kind of left off with the start of example 3, and what we were supposed to do was to write a function, take points that are in function notation, and write a function for that right there. And again, one thing I want you to keep in mind is all these functions are going to get written in mx plus b form. We need to find a slope. We need to find an intercept. Right? Now yesterday when we left off here, we said, hey, don't forget this. This g of 0 is like, well, I'm just going to back up. We said g of x. If you ever see a g of x, that's always like a,
G is 0.
we always said g of x is equal to y, right?
Y, yeah.
So we have this point, g of 0 equal 10. What the heck does this mean?
0, 10.
Yeah, basically what this is saying is when the x value is 0, what's your y value?
10.
10. So this really equates to a point, which is what, comma what?
0, 10.
Okay, everybody agree with that? And then when I assign g of 4 to equal -2 here, what point is that really, kiddos?
4, comma, -2.
4 comma -2, right? So, guys, do we have a formula to find slope between 2 points?
Yes.
We do, don't we? Okay, so let's do that. The first thing I need to do is find a slope, just like we were doing in the last section, answering those 2 questions. What's the slope? What's the y-intercept? That's what we're after here now. Okay, so let's first of all find my slope. What's that goofy formula for slope again?
Y2 minus y1, x2 minus x1.
So change in y over change in x. So if this is point 1 right here, and this is point 2 there, gosh, help me out.
-2 minus 10 over 4 minus 0.
All right, -2 minus 10 more. You're at -2, you lose 10 more. How far down are you? I'll wait till you've got that written down. I'm a little bit ahead of you, aren't I? All right, how about -2 minus 10 up top?
8, no, 12.
-12, right? So -12 divided by 4, how many times will 4 go evenly into 12? 3. So what's negative divided by positive?
Negative.
So slope's -3, isn't it, gang?
Yeah.
Okay. Guys, take a look at your 2 points. Take a look at your 2 points. We've only discussed this idea for the intercept, knowing that we had an intercept to begin with. So my 2 points, 0, 10, or 4, -2, which one helps us in determining the y-intercept? Which of those points would fall on the y-axis?
0, 2.
0, 10. So where would my line, what value would my line cross the y-axis? Or in other words, what's the y value in 0, 10?
10.
So the y-intercept is 10, right? Yeah, if I would plot this point 0, 10, if I would plot the point 0, 10, wouldn't that just be up 10 units on the y-axis?
Yeah.
That makes that your y-intercept, right? So guys, if the slope is -3 here, and the intercept is 10, what's that make the equation here?
Y equals -3x plus 10.
Now I want you to see something here, guys. When you get done, we know how to do this. We know how to write this as a slope-intercept form problem. The idea here, though, was to put this in some kind of what we call function form. So what do you think I'm going to rearrange or change y to now, if y was equal to initially what?
GX.
So the way I want you to write this now is say, okay, I know what y is equal to, so what was y equal to in the beginning?
GX.
So just in function notation, you're just going to replace the y with say, you know what, g of x is equal to, in the end, negative 3x plus 10. Okay, make that substitution right back there in the end. Again, everything's pretty much the same up to this point that I'm pointing at right up here, right? Everything that we've done is the same right to there, right? Instead of having y out front to write this in function notation, what do I want you to replace the y with now in the end?
GX.
In this case, g of x. Might be f of x. No. You guys with me on this? So do you understand what these mean right here? This just means the point 0 comma what? This means 4, negative 2. Find my m, which is the slope. Figure out which point gets you the y-intercept. Put your equation in slope-intercept form, and then the last part of putting this into function notation is to replace the y with whatever function they want right there. Okay? Again, guys, is it really anything different than we've done? It's just kind of a goofy way that they're presenting it, right? Okay, but we're pretty sly, and we get up early in the morning. They aren't going to throw one by us, are they? Oh, no. Natty, what's that? What you laughing about?
She's not over.
Oh, I thought I told a good joke.
Want to.
I thought I told a good joke or something. Wait a minute. That's not a joke. That's impressive. That should be hanging. That's art. That should be hanging on a wall in your house right there, right, Natty?
No.
Right above the living room couch. That would look so
Now we're
cool
not
on the wall.
moving.
What's that?
No one would even look at it.
All right. Guys, last thing I want to do then is to talk about using function notation and how this works with a real life problem. So, again, keep in mind, function notation, everything we've been doing is still slope-intercept form, isn't it? Isn't everything still slope-intercept form? So in the example I have up here for using function notation, it says you ride your bike at a speed of what? 12 miles per hour. That's a rate, isn't it? Okay.
Did you take that money that I received?
12 miles per hour. It says use function notation to write an equation giving the distance traveled as a function of time. Listen to my question, guys. Listen to my question. If you're going 12 miles an hour, how far have you made it in 1 hour?
12 miles.
How about 2 hours?
24 miles.
How'd you get 24? How about 3 hours?
36.
How about 6 hours?
24.
How about 6 hours?
Oh.
Oh, what did you just do?
4.
Wouldn't you take 12 times 6?
Yeah.
So couldn't I say right up here, guys, the distance that I make it, y, if I say y is my distance traveled, that would equal 12 times the number of hours I travel, wouldn't it? Okay, do you guys agree that the distance I travel, y, is equal to 12 times the number of hours I travel? So I said if x was 1 hour, if x was 1 hour, you would take 12 times 1, right? If x was 2 hours, 12 times 2. If x was 5 hours, 12 times what?
3.
12 times
I never realized that.
5, right? Okay.
I never realized my
So I've got that written right here. They're going to come back and say, put it in function notation. You might say f of x right here is equal to 12x right here then. Okay. Again, I just replace y with a what?
F of X.
Okay. This one here says, how long will it take you then to travel 12 miles? Well, right here, I'm going to say y is like my distance. My distance is equal to my rate times time. And x is going to represent the time. Okay, so if I come back to my original function, y equals 12x right here. This formula right up here says my y represents the what again?
The distance.
Distance. That's going to equal 12 miles per hour because that's how fast you're going, right? Times x, which represents the number of hours or time that you're traveling, right? Everybody agree with that? Okay. Guys, what is part B asking us to solve based on that equation that we wrote? It says how long, so we're trying to find a time, right? We don't know what time. It says how long will it take you to travel 12 miles? So is this distance of 12 miles going in for y, or is it going in for x?
X,
Ooh.
Y,
12 miles is a what?
distance,
It's a distance. Which variable up here represents my distance?
Y,
The y was. So if I'm going to put 12 in for what here in this equation?
Y,
So to solve this, I'm going to say 12 equals 12 times x, right? So how'd you get x alone there?
divide,
So how long is it going to take you to go go 12 miles? Ahead of myself.
1 hour.
You're going to get 1 hour, right? Excuse me.
I thought it was a minute. I thought it was a minute every miles per hour.
If you're going 12 miles per minute,
Oh wait, you're going.
if you're going
60. If you're going 60, then you go a mile a minute.
yes.
Yes. Okay.
Yes.
I was confused.
I was gonna say, if you're going 12 miles per second, that means you're going 720 miles. Well, no, wait. If you're going 12 miles per, did you say 12 miles per minute? 12
Yeah,
miles
I
per
think
second.
so.
12 miles per minute is 720 miles an hour.
That's fine. I will never, ever, ever do that. If you hit a tree, like disintegrate.
I was going 200. I wasn't, but I was in a car that was going 200.
You're stupid.
We almost hit a turkey too.
Questions have you guys got
You
today?
almost hit a turkey.
Turkey
Thank
came out in the middle of the road.
You almost hit a turkey.
Guys, help me out. Is the quick quiz attached to your notes?
No, but we should go outside now.
That didn't even make
Dude, no, we were going 200 and we almost hit a turkey.
Okay, here's what we're gonna do today. I
It was
want you to
scary.
write this
I
down
feared for
first.
my life.
I want you to write this down first. I'm gonna hand out this stuff.
Doesn't matter. I was in the car. If you hit something, it's not just the driver that's gonna die.
I'm pretty sure that. Okay,
Let
it
me
was a
stop the
really big
recording here.
It was a really big.
It was a really